Welcome to Math 1960, Section 301, Calculus 2. Today we will discuss integration using trig substitution. So, if I have an expression like this, so radical of a squared minus x squared, I can use this substitution to simplify my integration. X equal to a sine theta. And if I have this expression in my integration, um, radical of a squared plus x squared, I can use this substitution. X equals to a tangent theta. Also, if I have this um, expression in integration, I can use the following substitution to simplify the integration. X equal to a secant theta. Also, we're going to use an application of this substitution for definite interval. Okay? So this is the expression, and this is the corresponding substitution. This is the expression. This is the corresponding substitution. When I have this expression in my equation, this is the substitution. Okay. Integrate the following. I have d integration of d over x squared times radical of 4 minus x squared. So this is the following expression. Like we said, if I have a squared minus x squared, we use x equals to a sine theta as my substitution. At this point, I'm going to use x equals to, my a here is 2 sine theta, and then when we differentiate, we're going to have dx equals to 2 cosine theta d theta. Okay, that substitution will simplify the integration. So let's see how that works. So here I have dx, it's going to be this, so I'm going to substitute dx for that. So I'm going to have 2 cosine theta d theta divided by, so x squared b equals to 4 sine squared theta times integration of 4 minus 4 sine squared theta. Then, so I can simplify. Divided by 2, 1 divided by 2 is 2. So I have 1/2 outside cosine theta d theta divided by sine square theta. So we take out the 4, so it becomes 2. This is times 2. Radical of 1 minus sine square theta so Then I'm going to have 1/2. So 1 and 1, that would cosine theta d theta. This is going to be equals to cosine square theta because of the radical, that would be cosine theta. So here I'm going to sine square theta sine theta. So cosine theta cancels. So then it's going to be 1/4 integral of 1 over sine square theta d theta. That should give you, so that would be give you cosecant theta, and then integration of cosecant theta, that is tangent theta plus c. And then now we go back to our first assumption. So our first assumption is this. Raise this to say so this is my right triangle, this is my theta, and this is my x, this is my hypotenuse 2, then this area here is going to be equal to 4 minus x squared. So that means using this, I'm going to have 4. So the tangent to be radical minus x squared divided by x plus c, and that should be the final answer. Okay, in this section here, or in this problem, I want to find the integration of dx over x squared plus 9 raised to power 3 over 2. So this is based on the substitution that if I have this expression a squared plus x squared, we're going to use x to a tangent theta. Okay, so at this point I'm going to say x is going to be equal to 3 tangent theta. My a here is equal to 3. A squared is equal to 9. So that dx equals to 3. When I differentiate this one here, I'm going to get secant square theta theta. Okay, so we do the substitution. We're going to have 3 secant square theta theta divided by, so at this point I'm going to have 9 tangent square theta plus 9 raised to the power of 2. That would be equal to integral 3 divided by 27 secant square theta tangent square theta plus 1 raised to power 3 2 d theta. That should be equals to 1 over 9 integral secant square theta divided by secant to the third theta. That would be equals to 1 over 9 1 over secant theta, and that is going to be equals to 1 over 9, so secant theta, so that would give you the cosine theta. So when we integrate that, we will get 1 over 9 sine theta plus c. Then when we go back to our we should be having here x, here we have c, then here we should be having x squared plus 9. That gives me 1 over 9 x divided by square x squared plus 9 plus c. That should be the final answer. Okay, in this problem, so as we discussed earlier, we have x squared minus a squared under the radical, right? Substitution that we should be using is equals to x is equal to a secant theta. So that means at this point, we say a here being 2 is equal to 2. So x is equals to 2 secant theta. That means dx is to 2 secant theta tangent theta d theta. So at this point, when we plug in these, we're going to have secant square theta minus 4 divided by 2 secant theta. Here I'm going to have 2 times secant theta tangent theta d theta. So the secant and the secant cancels out, 2 cancels out, and then this one here give me 2 outside, so that would be secant theta minus 1, that would be equal to tangent theta times tangent theta. That would be equal to tangent square. So tangent square theta d theta, tangent square theta, and that should give 2 integral of secant square theta minus 1 theta. and that should give 2 tan theta minus 2 theta plus c. And then when we do substitution as well, we should get at the end, um, something like x squared minus 4 is 2 secant x over 2 plus c. So we want to find the area enclosed by the ellipse. So I'm going to have an ellipse that looks like this. So here would be 3, here is -2, and here is 2. So we want to find, first of all, find this area, and then we multiply by 4. We should be able to find the overall area. So first of all, we can express this one here in terms of y. So we're going to say y equals to 3, 2. We just solve for y. Exactly. So 4 minus x squared. Okay. And then now we're going to say the area, right? Area, where area under the curve. This curve is going to be equal to 3, 2 integral 4 minus x squared, right? X. Then we do the substitution. X is equal to 2 sine theta. That means dx equals to 2 cosine theta. So then we say the area is going to be 3 over 2 using 0 to pi 2. So that means when my x is equal to 0, that means theta is going to be 0. When my x is equal to 2, that means theta is pi over 2. Okay? Because you just change the limits using theta this time. Integral of 4 minus 4 sine theta. Sine square theta. Sine theta d theta. So then we're going to get 3 cosine theta. So cosine theta goes on square theta d theta, and then using these, going to be 1, 0, 5, 2. So then we're going to get 1 plus cosine 2 theta. So what I use is sine squared theta, cosine squared theta can be given as 1, 2 plus cosine 2 theta divided by 2. This is exactly what I use here. And then evaluate from 0, pi, 2, going to get, we're going to multiply this one here by 4. So multiply with 4 to get the area. So if this, so area So let's say area total, right? Area total is going to be equals to 3, that would be equals to 6, okay? 6 of integral 0 pi 2 of that one, which is going to be of 1 plus cosine 2 theta d theta. That should give you 6 of theta plus sine 2 theta divided by 2, evaluated at 0 pi over 2. That would give you 6 pi square units. Okay, here we're going to integrate. We will do integration that contains ax squared plus bx plus c, right? When we have that expression, or if we have like the quadratic function, how do we integrate such a thing? So like this right now, I have this quadratic function. I'm going to complete the square. Once I complete the square, I can be able to integrate function. So the first thing I'm going to do, I'm going to say this is this be expressed as x squared plus 6x plus 10. If I complete the square here, I'm going to have dx x squared plus 6x plus 9 plus 10 minus 9. That would be equals to integral of dx x plus 3 squared plus 1. 10 minus 9, 1. So I complete the square, and then if I take the integral of that using the u substitution, let u equals to x plus 2. That means dx. So then my integration is going to be u squared plus 1. That would be equals to tangent inverse plus c. And then substituting for what it is, we're going to have tangent inverse of x plus 3 divided by 1 plus c. So that would be how to integrate such a function. Alright, this is also by completing the square. So I'm going to have integration dx. So if I complete the square of x plus x, x squared plus x plus 1, that is to integral of dx. So x squared plus x, that would be equals to x squared plus x plus 1/2 plus 1/4 plus 1 minus 1/4. That would be equals to integral of dx of x x plus 1/2 squared divide plus 3 over Then we do the u substitution. Say u is equals to x plus 1 half. That means equals to dx. So my integration is going to be equals to the integration of du of squared plus 0, and that should give 2 squared 3 tangent tan inverse of u over square root 3 2 3 2 plus c. And now we substitute for what u is, and so it's square tan of so at this point I have x plus x plus 1 half here is 2